Good morning, afternoon, or evening, cats and dogs. This video comes from the lesson 5.8 guided notes on scale, drawings, and models. This is something we see quite often in real life when you're looking at blueprints, when you're looking at plans for the building of an airplane, for example, as you can see the image down below, the building or renovation of a house, for example. We also see scale drawings and models in textbooks, science textbooks, history textbooks, and we also often see those as well when we're talking about maps and things like that. So let's get right into it and let's talk about what a scale drawing or model is, along with the two main topics in this lesson, which are scale and scale factor. Those are the two things we're going to be asked to find in these guided notes. So again, a scale drawing or model is used to represent an object that is either too small or too large to be drawn or built at actual size. Some examples include model airplanes, buildings, and cars. So before they actually build an airplane or they build a building, they often have a model of that, whether it's a two-dimensional model, whether it's a three-dimensional model. Those things are used as scale drawings or models before actually building or constructing those things. Blueprints or other plans for construction. Maps in and of themselves are a scale drawing of an actual state or country or city, and it's going to be a smaller version of that. Often in your science textbooks, you'll see scale drawings or models of things that are too small for us to see, like atoms and electrons and things like that. DNA is another good example, and I know you work with that in science class. So sometimes we also use these to represent something that's too small, and we want to enlarge it so we can see what that really looks like. The lengths and widths of the model have to be proportional to those of the actual figure. If they're not, then the actual figure won't look the same as the model and vice versa. So we want those lengths and widths to be proportional, which is how we have a scale to represent those scale drawings or models, and how we have a scale factor that tells us how much bigger, how much smaller that model is to the actual figure. So the first topic we're going to talk about, I'm going to highlight this in yellow here, is scale. That's going to be one of the first things we're going to ask you to find. Scale factor is something that's different, so keep that in mind. The scale is determined by the ratio of a given length on the drawing or model to its corresponding length on the actual object. So I will always write model equals actual, which we can see in this third bullet point here. So we'll take our model measurement, set it equal to the actual measurement. Now we'll always make sure the scale is written as 1 unit equals something. So maybe 1 inch equals something, 1 centimeter equals something, but it's always going to be 1 unit, kind of like when we talk about unit rates, equals some other value. So an example could be 1 inch equals 3 feet. Now, is 1 inch actually equal to 3 feet? No, but 1 inch on the model represents an actual length of 3 feet. So that's what a scale is. Drawing measurement equals actual measurement. And again, 1 inch for the drawing, 3 feet for the actual measurement. The units of measure do not need to be the same. That's important for us. We do not actually have to have the same unit of measure here, whereas when we do scale factor in a few moments, the units of measure will need to be the same. So often you'll see like 1 inch equals 50 miles, or 1 inch equals 5 feet, something similar to that. Those units of measure do not need to be the same. Now, when we talk about scale factor, this is going to be a fraction. The way I remember this is scale factor. The word factor starts with F, fraction starts with F. So it's when you take your scale and you write it as a fraction in simplest form, but with the same units of measure. That's really important. So we might need to do some conversions here. So let's look at example 1, a really simple example. Suppose a scale model has a scale of 2 inches equals 16 inches. It's not written in terms of 1 inch, but if our scale 2 inches on the model represents 16 inches in real life, you can write 2 inches over 16 inches. We can cross off the inches since we have the same unit of measure. We get 2/16, which reduces to 1/8. That means the scale model is 1/8 the actual size. Example 2 is a really good one for us. I'm going to put a little green highlighted dot next to it. Suppose a scale model has a scale of 1 inch equals 3 feet. Now these units of measure are different. So we can start by writing 1 inch over 3 feet, so model over actual. We're going to convert 3 feet into inches. That's 36 inches. 3 times 12 is 36. Now we can cross off our common units of measure and we end up with a scale factor of 1/36. And again, this means that your model or drawing is 1/36 actual size. All right, so let's take a look at some examples. Let's begin with numbers 1 and 2. On a scale model of a building, the highest point of the building is 14 inches. The actual height of the building is 175 feet. What is the scale of the model? Keep in mind, scale is model equals actual. So on the model, our building is 14 inches. The actual building is 175 feet. So we can write 14 inches equals 175 feet. We do want to put it in terms of 1 inch. So we do that by dividing both sides or both of these numbers by 14. That will get us excuse me, that 1 inch equals 12.5 feet, and that is our scale. Let's take a look at number 2. On a scale model of a building, the highest point of the building is 14 inches. The actual height of the building is 175 feet. This one's asking us to find the scale factor, so this is going to be a fraction. You notice how it's the same information from the previous question. So we set up model to actual. So that will be 14 inches over 175 feet. But keep in mind, we want our units of measure to be the same. So I do that by converting 175 feet into inches. I do that by taking 175 times 12, which is 2,100 inches. So I can write this as 14 inches over 2,100 inches. I can now cross off my common units of measure. 14 out of 2,100, when I put it in my calculator, is going to get me 1 out of 150. If you happen to have a calculator that won't let you put in more than 3 digits in the denominator of the fraction, let me know. We can talk about a way to get around that. Unfortunately, that happens on a few versions of the calculator. It's a TI calculator. So if it's not working for you, let me know. But the way I would do this is I would divide top and bottom by 2. And then that would end up getting us 7 over, let me go ahead and calculate that, make sure I have it right mentally, 1,050. And then from there, I would want to see if both of those numbers still divide by 7, since that's the only number they can divide by. They do, and you end up getting 1/150th. So you might have to do a little bit of the work on your own if your calculator does that, but it's no big deal. All right, let's go ahead and flip the page and let's take a look at numbers 3 and 4. So number 3, on a set of landscape plans for a new garden, the length of the garden is 18.5 inches. If the actual length of the garden is 111 feet, what is the scale of the plan? So again, it's asking us for scale. That's going to be model equals actual. So we take our model measurement, which is 18.5 inches. We set it equal to the actual measurement. And again, it says the actual garden is 111 feet. So we have 18.5 inches equals 111 feet. Divide both of these values by 18.5. So 111 divided by 18.5 gets us 6. So we get 1 inch equals 6 feet. Now, number 4 is tied in with this one, just like we had on our previous question. So it says on a set of landscape plans for a new garden, the length of the garden is 18.5 inches. The actual length of the garden is 111 feet. What is the scale factor? Keep in mind we're finding scale factor here, which is a fraction. So it's going to be model over actual. Now for this question, I actually chose to use my scale that I came up with in number 3. Could I write 18.5 inches over 111 feet? Sure. But then we do have the issue of having a decimal in the numerator and having to get rid of that. So what I did was I used 1 inch over 6 feet. I then converted 6 feet into inches. That will be 72 inches. I took 6 times 12 to get that. So if I end up with 1 inch over 72 inches, that doesn't reduce at all. And we just end up with 1 over 72 as our scale factor. Now, if you use the 18.5 over 111, you'll get the same solution. You'll have to convert 111 feet into inches, which is 1,332. Again, the problem with that, though, excuse me, I had a tickle in my throat, is that you have 18.5 inches over 1,332 inches. I'm sorry about that. Got a scratch in my throat as I'm talking. We will want to get rid of that decimal, though, if your calculator won't let you put that in as a decimal. So you'd have to move the decimal point to the right one place and get 185 over 13,320, which can be problematic depending on how your calculator works. It might not simplify that as easily for you. So you can use either the simplified scale or what's given to you in the problem. I do want to stress that. All right, let's move ahead to number 5. So number 5, if the scale of a blueprint of a building is 1 inch equals 8 feet, it should be comma there, what is the scale factor? So scale factor, remember, is a fraction. Keep that in your mind. So that's going to be model over actual. So that will be, I'm actually just going to pull all this down, 1 inch over 8 feet. But I do want to convert 8 feet into inches. So take 8 times 12 to get 96 inches. We can cross off our common unit of measure here and just end up with a scale factor of 196. All right, number 6. Drew is putting in a new patio in his backyard. On the set of plans that he has made, ½ inch represents 8 feet. What is the scale for his plan? So that is model equals actual. So on the model, we know that a ½ inch is going to represent 8 feet in real life. So we can set 1/2 inch equal to 8 feet. Notice how I'm putting labels here. Now, for my final scale factor, I do want to mention you don't need labels on that. We are crossing off that common label. It doesn't matter what the label really is. It's just that your model or blueprint is going to be 1/96 actual size. You don't need a label. When we're doing scale, though, we definitely need to have our labels on our final solution, but I like to put my labels throughout so I know when I need to convert things and so forth. We want to get this in terms of 1 inch, so we can divide both of these numbers by a half. That's going to get us that 1 inch represents 16 feet. Now, you might also recognize that you could just multiply both of those numbers by 2 to get this in terms of 1 inch. All right, let's take a look at number 7. This one is an example like in a science textbook where we're actually enlarging that figure, so it's going to end up being sort of a different scale. So in an illustration in a textbook, the length of a fly is 4 inches. The actual size of an average fly is 0.2 inches. What is the scale of the illustration? So we're going to set model equals actual. This time, though, the model we're talking about, the illustration in the textbook, is 4 inches. It's actually a bigger value. That happens sometimes when we're enlarging something. And then the actual size of an average fly is 0.2 inches. So we will set 4 inches equal to 0.2 inches. Divide both of these numbers by 4, and we will get a scale of 1 inch equals 0.05 inches. All right, let's go ahead and take a look at number 8. So this again should just be one sentence really. I've never fixed this typo, or at least not on my PDF document that I have. If the scale is 10 inches equals 1 foot, what is the scale factor? And again, in your mind, you want to think scale factor is a fraction. So we set model over actual, so that's 10 inches over 1 foot. Clearly 1 foot is 12 inches. Now that I have my common units of measure, I can cross these guys off and simplify 10/12. That will simplify to 5/6. So again, you notice in this lesson, which is probably brand new for you, there's really only 2 major topics. We're talking about scale, which is model equals actual. It's just going to be like an equation almost. And scale factor, which is going to be a fraction. All right, let's go ahead and flip the page. And this time we have a table to take a look at. And you're going to notice the table's already filled in, the work's down below. This is one that after I show you the lobby and the science lab, I would suggest maybe trying the other rooms on your own, pausing the video, and then checking it by restarting the video when you're ready. So the directions say on a set of architectural drawings for a new school building, the scale is 1/4 inch equals 2 feet. Write and solve a proportion to find each of the missing lengths of the rooms in the table below. So the lobby and the science lab are already done for you down below. So let's go ahead and take a look at those. And I know all the rest of this is uncovered already, but just ignore it for now. So we're comparing inches to feet. I'm actually going to set up a proportion to find my solution. That's not the only way to do it, but it does ask us to write and solve a proportion. So that's what I'm going to do to find my solution. So the scale that's given to us, even though it's not in terms of 1 inch, although you could convert it to that, is that a 1/4 inch, I wrote it as 0.25 inches, is equal to 2 feet. So inches over feet. For the lobby, we're given that the actual length is 16 feet. So I put that 16 on the bottom since that's where feet is. I put a variable like x on the top because I'm trying to find the length on the drawing in inches. So let's go ahead and cross multiply to solve this. 2 times x is 2x. 0.25 times 16 is 4. Divide both sides by 2, and we end up getting x equals 2 for our solution. In the science lab, we had, again, this same scale. You're going to see this for every single one of these. But for this one, we're given the drawing length of 1.5 inches. So we'll put that on top. Now cross multiply, we get 0.25x equals 1.5 times 2, which is 3. Divide both sides by 0.25, and we get x equals 12. So you can see I filled that in up here. So 2 inches is the drawing length of the lobby, and the actual length of the science lab is 12 feet. So I would suggest at this point pausing the video and trying the band room, auditorium, gymnasium, teacher's lounge, and cafeteria to find your solutions for those, and then restarting it when you're ready so we can check the solutions. All right, so I really hope you've had a chance to try the remaining rooms. Let's start with the band room. So your drawing length was 4 inches. You should get an actual length of 32 feet. So for this one, I set 0.25 over 2, and then we had 4 inches, which was given. We want to find the actual length, x, in feet. So I took 0.25, sorry, that should be a 0.25x right there. I just realized that it says 0.5x. I fixed one of them, but I didn't fix both of them, apparently, when I recopied. So this should be 0.25x. Minimize that and fix that. My apologies on that mistake there. So we have 0.25x equals 8. We get that from taking 2 times 4. Divide by 0.25, and we will get x equals 32. The auditorium, you should get 7 inches for the drawing length. So we set up 0.25 over 2, and then x over 56 since the actual length is 56 feet. Go ahead and cross multiply. We do 2 times x equals 0.25 times 56, which is going to get us 14. Divide by 2 to get x equals 7. All right, let's check our last 3. My kids are making some sort of noise downstairs. I don't know if you can hear that. The gymnasium, we start off with that 0.25 over 2. 0.25 inches represents 2 feet. We're given a drawing length of 13 inches. Put 13 over x. Cross multiply, you got 0.25x, I have it right on this one, equals 2 times 13, which is 26. Divide both sides by 0.25, and you get x equals 104. So the actual length of the gym is 104 feet. For the teacher's lounge, we've got 0.25 over 2. On the drawing, it's 1.75 inches, so put that over x. Cross multiply, we get 0.25x equals 3.5. Divide by 0.25 to get x equals 14. So the actual length of the teacher's lounge will be 14 feet. And finally, we have the cafeteria from this section here. 0.25 inches over 2 feet. We are given an actual length of 48 feet. So put x over 48 on the right. Cross multiply, we get 2x equals 12. Divide by 2, and that means we will have a drawing length of 6 inches. So hopefully those weren't too bad for you. One thing that can help is if you do convert it in terms of 1 inch. So if you say 1/4 inch equals 2 feet, multiply both of those by 4 to get that 1 inch represents 8 feet. That can actually help you find really any of these. You notice to get from your actual length to your drawing length, you would just divide by 8. And to get from your drawing length to your actual length, you would just multiply by 8. That's helpful if you put your scale in terms of 1 inch. These problems did ask us to write a proportion, but if they didn't, you could find your solution in whatever way works best for you. All right, so let's finish this part up and let's take a look at the scale factor. So I took our scale, which was 0.25 inches, and put it over 2 feet. I took the scale that was given to us, which was 0.25 inches over 2 feet. I did convert 2 feet into inches, so we have the same unit of measure. But my calculator, unfortunately, will not let me put in 0.25 over 24. So what I did was I moved the decimal point to the right 2 places in both of those numbers to get 25 over 2400, again, to the right 2 places to get rid of the decimal point. The other option you have is to multiply the top and bottom by 4 and then simplify 25 25 over 2400, which is 1/96. Now, again, there's lots of ways to do this. So if you look back when we converted it into 1 inch equals 8 feet, which I think we saw in a previous question, 8 feet is 96 inches, so you would just get 1/96. So whatever works best for you. Again, there's multiple ways to come about the scale factor here, but you want to choose the method that's easiest for you personally. All right, so we do have a handful of questions to finish up these guided notes. Let's take a look at numbers 9 through 13, our remaining questions here. So number 9, it says a set of landscape plans shows a flower bed that is 6.5 inches wide. The scale on the plans is 1 inch equals 4 feet. What is the width of the actual flower bed? So it's not asking us to find a scale factor or anything here, but we are given the scale like we were in that last set of questions with the table. So I can set up inches to feet. 1 inch on the model represents 4 feet in real life, and I'm given a 6.5 inch wide length width, I guess, in our flower bed drawing on this set of plans. So I put 6.5 on the top since it's inches. And when I go to cross multiply, it's really straightforward. 1 times x is just x. So basically all you're doing is taking 4 times 6.5. Now it doesn't say you have to set up a proportion here. So if you realize that 1 inch represents 4 feet, and you know you only need to take 4 times 6.5 to get your solution, then go ahead and do that. Just don't forget to put a label on your answer as well, because I often have students forget that label. They just put the solution without a label on it. I want to know that you know this is 26 feet and not 26 inches. Number 10, really similar. The blueprint of a building shows that its height is 11.4 inches. If the scale on the blueprint is 1 inch equals 6 feet, what is the height of the actual building? So we can set up a ratio of inches to feet. We've got 1 inch represents 6 feet, and we have 11.4 inches, which is given to us on our blueprint, our model. So we put that on the top. Cross multiply, 1 times x is just x, so you just take 6 times 11.4, and the height of the actual building in this case will be 68.4 feet. All right, we've got 3 more questions. I do want to read this box down here. It says, remember that scale looks like 1 inch equals 40 miles, something equals something else, or 1 centimeter equals 100 kilometers. And scale factor is written as a fraction. So you want to remember these things moving forward. So number 11, the penny coin has a diameter of 3/4 inch. Suppose a scale drawing has a diameter of 3 centimeters. What is the scale of the model? Remember, that's model equals actual. Well, the model itself is going to be 3 centimeters. Ooh, we want to flip these around. So we've got 3 centimeters. I realized I typed that in wrong when I wrote it. Equals 3/4 inches in this case. So 3 centimeters that are on the drawing is going to represent 3/4 inch. This is a good example of fixing your answer in real time. So 3 centimeters on the drawing represents 3/4 inch in real life. So we actually want to divide both of these by 3. You're going to see I have divide by 3/4. Don't copy that down. Let me fix it. So we want model equals actual. So this is going to get us, and I'm going to have to fix this solution. No big deal. So we've got 1 centimeter on the model, and we want to take 3/4 divided by 3, and that is going to get us 1/4 inch. I'm going to type that the right way. Let me fix that. There we go. So talking through this question again, just because I had to make some corrections. Again, my apologies, that happens sometimes. It's always important to read carefully. So the model is 3 centimeters. The actual coin is 3/4 of an inch. So we set those equal to each other. Divide both numbers by 3. 3 divided by 3, of course, is 1 centimeter. So 1 centimeter on the model. We take 3/4 divided by 3 is equal to 1/4 inch in real life. All right, number 12, I know I did not make a mistake on. So number 12, the pillars of the World War II Memorial in Washington, D.C. are 17 feet tall. A scale model of the memorial has pillars that are 5 inches tall. What is the scale of the model? So we want to set our model equal to actual again for scale. So our model will be 5 inches tall, so we'll put that on the left. actual is going to be 17 feet. Sometimes they're not in the same order in which they're written in the problem. So you've got 5 inches equals 17 feet. Divide both of these by 5, and we will end up getting 1 inch represents 3.4 feet. We get that by taking 17 divided by 5. So 1 inch on the model represents 3.4 feet in real life. All right, the last thing is a multiple choice question. I throw these in because, again, students often struggle with these, or they choose one of the wrong answers because they seem pretty obvious out of the gate, but we really want to make sure we read carefully because it's easy to make mistakes, myself included. So number 13, it says the scale on a set of blueprints is 3 inches equals 4 feet. What is the scale factor? Clearly a fraction. Luckily, they're all fractions here. So we'll set 3 inches over 4 feet in this case, but we want to convert 4 feet into inches. Now that is 48 inches, taking 4 times 12. We can cross off the inches here and simplify 3/48. Which fraction does that simplify to? If you chose 1/16, you are correct. This is going to simplify to 1/16. So our scale factor for this is 1/16. I often have students who choose C because they just put 3 over 4 and think they're done. We'll sometimes have students who choose B because they recognize they need to convert 4 feet into inches, but they don't do anything with that 3 on the top. So be really careful with these problems. All right, so again, main topics in this lesson. Scale is going to be model equals actual, so basically an equation, something equals something else. Whereas when we talk about scale factor, those are going to be represented as fractions with the same unit of measure. Thanks for listening.